Tom at Snake River Base. Last time we talked about your fall arc and where you are at any given time relative to the object, depending on how fast you're moving forward when you leave the exit point. This time I want to talk about how much time that gives you to react to an off heading. So what I want to do is I want to talk about at any given time how many seconds you have until you strike the object. We're going to say that an average base canopy moves 5 or 6 miles per hour forward with the brake set after opening in some kind of deep brakes for slider down. That's an average. Different canopies going to move different, but we're just going to use that number. To simplify, we're going to say that's about 2.5 meters per second. So we're going to say the canopy's forward speed is 2.5 meters per second. Remember our first jumper here, Usain Bolt, the world's fastest human? Usain Bolt, after a 1 second delay, opens 10 meters away from the object. If his parachute moves 2.5 meters per second towards the cliff, that means Usain Bolt has 10 divided by 2.5, 4 seconds to turn his canopy around. What about our average base jumper? Well, our average base jumper, who moves at half of Usain Bolt's speed as he leaves the exit point, is 5 meters away from the cliff. His canopy also moves 2.5 meters per second, so he has 2 seconds to save his life. And our fat old guy? The fat old guy has only moved 2.5 meters away, so he has 1 second to save his life. These numbers will just continue adding as we go deeper in delay. So the longer the delay you take, the more time you have to save your life, and the more help you get from your exit speed. Usain Bolt, at 2 seconds, is 20 meters away. His canopy is moving 2.5 meters per second. 20 meters divided by 2.5 meters per second means that Usain Bolt has 8 seconds to turn his canopy away from the object before striking it. Our average fit young base jumper has moved 10 meters and therefore has 4 seconds to turn his canopy away. And our fat old guy has moved 5 meters and therefore has 2 seconds to save his life on a 2-second delay. At 3 seconds, the numbers continue adding, and you can see that Usain Bolt has 12 seconds to save his life. Our average base jumper has 6 seconds to save his life, and the fat old guy has only 3 seconds before he strikes the object. Why is this important? Well, it's important because the difference between 12 seconds and 3 seconds is a lot when you're talking about how much time you have to get out of the line twist, maybe grab a riser, turn the canopy, or go through the twist and turn the canopy around. What we really see here is that how fast you run is super important. But the other thing that's important is what kind of delay you take. Because our average jumper, by taking a 2-second delay, can double his working time. Usain Bolt takes 1 second, only gets 4 seconds. Average guy takes 2, goes deeper, and gets 4 seconds. The lessons here are 1, run as fast as you possibly can. There's a big scary monster behind you and it wants to eat you. The further away from it you get, the safer you're going to be. And 2, go deep. The more delay you can take, assuming you're safe from striking the ground, the more delay you can take, the safer you are from the object behind you. And striking the object injures and kills a lot more jumpers than striking the ground. So our basic lessons from this are run fast and take as much delay as you can.